Dimensional analysis, aka fun with conversion factors. Conversion factors really are important. It's not just a busy work task that we give you in chemistry classes. It's things that you can use in a practical sense. In other videos, I've mentioned that my kid got weighed in kilograms after I gave birth, and my husband had no idea what that meant. And the nurses weren't able to convert to pounds for us, so I had to do it, which was super fun right after having given birth. Or the dry weight of our trailer. You know, can we tow the trailer with the tanks full? Landers crashed on planets because conversions weren't done correctly. So it's not just a matter of, hey, busy work in chem class. No, this is something really practical. It's a problem-solving skill that you can use both in science and in everyday life in practical applications. So let's do some dimensional analysis. Okay, start off a little bit easy here. I'll give you a single step conversion. We want to know how many inches there are in 6.27 yards. Okay. So we have yards to inches that we want to do. Okay, so we have our 6.27 yards. We need to cross off yards. We're going to put 1 yard on the bottom and 36 inches on the top. Okay. We do the math, and we're going to get 225.72 inches, because yards cancel. 226 inches. Okay? All right. Now, other times, you may need to find conversion factors. Maybe they're on a note sheet, or maybe you have to derive something from it, or maybe it's just common knowledge. So here's this problem. We have somebody that went to Vegas and played nickel slots. And while playing nickel slots, this person won 2,410 nickels. All right, cool. Slot machines. They were done with slot machines. Now they want to go play the tables. And so they want to cash out their nickels to get some $3 chips. Okay? So what we're trying to do here is we're trying to convert our nickel winnings into chips. So we need to go from nickels over to chips. Now each chip is worth $3. So what we're actually going to have to do is a two-step conversion. We're going to need to go from nickels to dollars and then over to chips. Okay? So if you don't know how many nickels there are in a dollar, I have conveniently provided you with an image that shows the number of nickels there are in a dollar. Okay? There are 20 nickels per dollar. So we're going to take our 2,410 nickels. Okay. We have $1 for every 20 nickels. All right. And then we get 1 chip for every $3. So nickels will cancel, dollars will cancel, and we are left with our $3 chips. When we run this, we're going to get 40.1667. Now, when we have a practical problem like this, sometimes the rounding follows some interesting rules. So if we think about Vegas and we think about this, if I try to go get chips, what's going to happen? Well, they're going to, no matter what happens, round down to the smallest whole number of chips. So how many chips can I get? Or how many chips can you get? 40 chips. Because that's the smallest rounding for that. Okay? All right, let's do a few more. Okay? All right, here we want to go from inches to centimeters. Okay, and remember we have that 2.54 centimeters equals 1 inch. Okay, so we're going to take our 60 inches times 2.54 centimeters and 1 inch. We get 152.4. We have 3 significant figures, so we'll cut it there and we get 150. The tracking is not always perfect on this. We get 152 centimeters. Okay, let's try another one. Okay, so we want to go from kilograms to pounds. Okay, so there's a conversion. If you look at all the slides, one of the slides when I started talking about the metric system and I introduced conversions, there is a slide that has a whole bunch of conversions on it, and then there's a slide after that that has a few very commonly used conversions that you see more frequently. And what you'll find out is there's 2 ways we can do this. We can go from kilograms to grams and then grams to pounds, because we have a grams to pounds conversion. Or we can go directly from kilograms to pounds because there is a conversion for that. And it's 2.205 pounds for every kilogram. So I have 2.205 pounds equals 1 kilogram. Okay? All right, so we take our 80.7 kilograms times 2.205 pounds for 1 kilogram. And we get 177.944. Okay, my conversion factor has 4 sig figs, but this right here, we only have 3 sig figs, so we have to cut here. The 9 means we round up, so we get 178 pounds. Okay. All right. Let's try another one. All right, so here's one that you might encounter in a medical setting. Well, you may encounter the kilograms to pounds too, because they're weighing everybody in kilograms. If you want to know pounds when you go to the doctor, or if you have a patient that gets weighed in kilograms, they might ask you. But here's another one. Now, here's a medication question. So there's some ampicillin that treats an ear infection. So a lot of medications are dosed based on weight. So this particular medication needs to have 115 milligrams of meds for every kilogram of body weight. Okay? Intake on a kid that needs this medication, this kid weighs 34 pounds. So let's see, how much medication should this child receive? So what we are trying to do is we are trying to go from weight of our kid to amount of meds. Okay, so, and I'm differentiating that. I'm not just doing pounds to kilograms, because I have 2 situations here. I have how much the individual weighs, and then I have this dosing of how much meds. So we have to differentiate that when we set this one up. It's not just pounds to milligrams, it's pounds of kid to milligrams of meds. Okay, so we're going to go from pounds of kid to kilograms of kid to our milligrams of meds. Because our conversion, we have milligrams of meds for every kilogram that the person weighs. Okay? So we are going to take our 34-pound kid, and we get 1 kilogram of kid for every 2.205 pounds of kid. And then according to this right here, we have 115 milligrams of meds for every 1 kilogram of kid. Okay? So we get 1773.24. Now, whoever took this kid in didn't do a very good job with significant figures because we only have 2 sig figs there for the weight of our kid. So we only get to keep 2 sig figs here, so we're going to have to cut it there. So we can write this in 2 ways. We can write it with trailing zeros and no decimal point, or we can write it in scientific notation. So we can write it as 1800 or 1.8 times 10 to the third milligrams meds. They both mean the exact same thing. Okay. All right, let's try one more. Now, this is a little bit different. Okay, so sometimes we're dealing with a situation where we have to square things. How do we handle that? Well, what we need to do is we need to go from yards squared to feet squared. Okay, so there is a conversion where we have 3 feet equals 1 yard. Now, here's the thing though, that's not squared. So how do we handle this in this sort of a problem? There's 2 ways we can do this, okay? I can do 2 yards squared times 3 feet and 1 yard. That takes care of 1, okay? Times 3 feet and 1 yard, and then that takes care of the other, and I get 18 feet squared, or I can square the entire conversion factor like that. Okay, so that's how we deal with it when it's squared. So conversions, lots and lots and lots of conversions. Okay, that's a big part to the foundational stuff to an introductory chemistry course. So lots of conversions. At the end of this chapter, I have a whole bunch of extra problems for you to practice on your own. I will give you the final answers to them, but I will not solve them outright because you won't learn these if you just wait for me to solve them all. You have to get in and you have to work problems. You have to try these. The only way you're going to get good at them is if you do them a whole bunch of times. And you have to do them on your own. You have to struggle with them. Part of learning, part of this process at this stage of the game in college is for you to engage with the material and struggle with it and really delve into it. Just copying what I do over and over again isn't what's actually going to cement it into your brain. You have to be the one to actually do it. So practice these. Make sure you can do these. Go back and follow along if you need to. And then when you're all done with this chapter, try the additional problems and check your answers against what I have, and really practice these because it's definitely a crucial thing that you're going to need to know how to do. It's going to come back more than once this semester. Once we get finished with this chapter that we're working on, it's not just that, oh, our conversions are going to go away, we'll never touch them again. You'll use them for things throughout the semester. And then when we actually start talking about chemicals and we start looking at reactions, then we're going to come back to all of this because instead of converting things like yards and feet, we're going to start doing things like grams to moles and actually figuring out what happens in our chemical reactions. So super, super important that we're able to do these going forward.